Well, howdy, 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 kiddos. This topic that we're going to cover today does not quite follow along with electron configurations, but the reason it's included in Unit 3 is because electrons have the ability to give off light. And with light comes a lot of different things that we can talk about. So today we're going to talk about the electromagnetic spectrum and how it contains waves. And then in another video, we're going to talk about how light can actually behave like a particle and has energy. And so we're going to talk today just about the electromagnetic radiation that we've seen. And most of you have heard of a few of these. It's a series of energy waves that include radio waves. We know about radio. Microwaves. I'm sure lots of us have used the microwave. Visible light, what we see. Infrared, ultraviolet, UV rays, X-rays, and gamma rays. And so what we need to know is what the wave looks like. Is it short? Is it long? Is it dangerous? How fast does it go? And can we classify them based on those variables? So here's the spectrum. And what we're going to find here is that radio waves have a wavelength in meters that is 10 to the fourth or 10 to the second, or even just regular base unit meters. And those are going to be really long waves like this. And when we get to the other side of the spectrum, gamma rays, these guys, their waves look like this, almost like we're coloring. And somewhere in the middle, you're going to have visible light that's somewhere in the center. So if I tried to connect these as best I can, it would get, and that's not the best, but that's kind of what's happening here. Radio waves, we hear them in the car. You've got AM and FM, different kinds of radio. Microwaves has a certain frequency where we can actually heat up water based on the speed of the wave. Infrared, we can see deeper than just basic red, and usually we use that when we're hunting, night vision, things like that. The visible light spectrum is split into the things that we can see, and a lot of us know the colors of the rainbow. Roy, red, orange, yellow. Roy, G, and then Biv would be blue, indigo, and we don't quite have it here, but violet would be over here, or purple. And then above that, you have ultraviolet rays, and these waves are getting a little bit more, they're getting shorter, and they're a little bit more dangerous. So this is UV rays, and we know that we can get sunburn based on those. They come through the atmosphere, and they are different kinds. There's A, B, and C. And then you have X-rays, which can penetrate through flesh and can be stopped, though, by bone. And so because of that property, we can actually get X-ray imaging, and we can tell what things are broken and what things need to be fixed inside of your body. Gamma rays are the most dangerous. Their wavelength is very, very small, and they can penetrate through our bodies, and actually they have the ability to kill off cells and destroy tissue. And so what we can do in some circumstances is we can target gamma rays at body flesh, and we can actually destroy tissue. And a lot of times this is used in order to treat cancerous growths. We like to destroy the cancerous growth so that we can have a hope of killing it off. So a good thing, but also can be a very destructive thing. So we need to know the parts of these waves, and there are several different parts. You need to go ahead and draw this on your notes, find space, and sketch out a wave. And we're going to label the different parts. So from crest to crest, this is where I'm going to start, crest to crest. The crest is the top of the wave, kind of like a crest of a mountaintop. From crest to crest, so if I continued that on, it would kind of continue in here. That is the wavelength. Now you could also say the wavelength is trough to trough. The trough would be almost like a watering trough where you can hold water, right? So the trough is down here. Amplitude is the height of the wave. Amplitude goes from crest to trough. Some people also measure amplitude from the crest or the trough down to what we call the origin, which is the middle of the line. The more waves that pass through a certain point, we call that a higher frequency. The lesser amount of waves would be a lower frequency. So amplitude is the height of the wave from the origin to the crest. So if I have the origin, I have a wave, it would be the origin to the crest, or you can actually do trough to crest. Wavelength is the distance between the crests or trough. The units of wavelength are usually in meters, but you can have any metric prefix of centimeters, millimeters, decameters. You can change the base unit there depending on what the question's asking for. Frequency, which we're going to see in both particle aspects of light and waves, the number of wave cycles to pass a given point per unit time. The units of frequency can be multiple things. 1 over seconds, which these two are the same, or what we call hertz, and perhaps you've heard of different frequencies. These are the variables of waves.